Welcome back to another lesson in MCR3U. Today we'll be looking at linear quadratic systems. A linear quadratic system contains a parabola and a line with the same set of variables. The solution to a linear quadratic system is the intersection point of a line and a parabola. There's three ways that a line and parabola can intersect. And if we look at this first picture on the left, we see that there's 2 points of intersection. So here there's 2 points of intersection, 2 points of intersection, or for short, we just write POI. And this line is called a secant line. Here, again, we see in the middle picture that the line crosses the parabola at 1 point. And so here there's 1 point of intersection. And this line may be called a tangent line. And then lastly here, as we see in the picture on the right, there is no points of intersection. Okay, so let's look at some practice examples. So here it says Maria is a set designer. In one scene, the banner will hang across a parabolic archway. To make it look interesting, she will put the banner on an angle. She sets the banner along a line defined by the linear equation f of x is equal to 0.4x plus 7.2, where x represents the horizontal distance and y represents the vertical distance in meters from 1 foot of the archway. The archway is modeled by the quadratic equation g of x is equal to negative 0.48 x squared plus 4.8 x. What points along the archway should she attach the banner? And here, so we see that we have two equations. We have f of x being our linear equation, which is 0.4x plus 7.2. And here we have g of x is equal to negative 0.48x squared plus 4.8x. Here we can write that f of x and g of x are equal to y. And therefore, because they're both equal to y, we can equate the two. We can equate f of x is equal to g of x. And so here we can write that 0.4x plus 7.2 is equal to negative 0.48x squared plus 4.8x. And here what we want to do is we want to move everything to one side and make the equation here equal to 0. So here, we're going to move 0.4x to the other side, so we're going to subtract, and we're going to subtract 7.2 by both sides as well. So here we get 0 is equal to negative 0.48 x squared plus 4.4 x minus 7.2. And to make this easier for us to calculate, we're going to multiply here by negative 100. So multiplying by negative 100, we'll get 0 is equal to 48 x squared minus 440x plus 720. And now we're going to divide this by 8, which will now give us 0 is equal to 6x squared minus 55x plus 90. And so here, to solve for our equation, we're going to put this into our quadratic formula. Here we have x is equal to negative b of 55 plus or minus square root b squared, negative 55 squared, minus 4a, which is 6, c, which is 90, over 2a, so 2 times 6. So here we'll get x is equal to 55 plus or minus square root 865 over 12. So here we'll have two answers. We'll get x is equal to 7.03, and also x is equal to 2.13. So here, if we sub it into one of our equations, so here we'll sub into f of x. So here we see again, f of x is equal to 0.4x plus 7.2. And here we will sub x is equal to 7.03 first. And so here we have f of 7.03 is equal to 0.4 times 7.03 plus 7.2. And that will give us 10.01 meters. And then we'll also here sub x is equal to 2.13. So here we'll get f of 2.13 is equal to 0.4 times 2.13 plus 7.2, which is equal to 8.05 meters. And so here it says, at what points along the archway should she attach the banner? So here, Maria, so therefore Maria should attach the banner. So Maria should attach the banner at 7.03 and 10.01 and 2.13 and 8.05. So those are our coordinates. Again, x value represent horizontally how far, and then the y values represent vertically how far, and that's where the 2 points of intersection are. Okay. So the next thing we'll look at here is using the discriminant to determine the number of points of intersection. And so here we will determine the number of points of intersection of the quadratic and linear function. So here we have f of x is equal to 3x squared plus 12x plus 14, and g of x is equal to 2x minus 8. And so here we see again that f of x, we can write f of x is equal to g of x. And so we'll equate those two together. And so here we'll have 3x squared plus 12x plus 14 is equal to 2x minus 8. Here we want to move everything again to one side. So here we'll move this, we'll subtract 2x from both sides, and we'll add 8 to both sides. So here we have 3x squared plus 10x plus 22 is equal to 0. Again, in standard form, again, our 3 is our a value, 10 is our b value, and 22 is our c value. So remember, our discriminant formula is b squared minus 4ac. That's our discriminant. And here we have b squared, so we have 10 squared minus 4 times 3 times 22. So here we get 100 minus 64, or sorry, minus 264, which is equal to negative 164. And remember, again, if discriminant is less than 0, and therefore there is no points of intersection. Okay, so here it says determine the value of k such that g of x is equal to 3x plus k intersects the quadratic function f of x is equal to 2x squared minus 5x plus 3 at exactly 1 point. And so here we know that if it intersects at exactly 1 point, that means that the discriminant will be equal to 0. First thing we're going to do is, again, we're going to equate f of x to g of x. And so here we have 2x squared minus 5x plus 3 is equal to 3x plus k. Here we'll move everything to the other side, so minus 3x. And here we'll subtract by k, and here k will be considered a constant. So here, if we rewrite our equation, we get 2x squared minus 8x plus 3 minus k is equal to 0. So here our a value is 2, our b value is negative 8, and our c value is 3 minus k. So again, we know that the discriminant is equal to b squared minus 4ac. And here, because we're trying to look at the intersection at exactly 1 point, we know that the discriminant is equal to 0. So here we get 0 is equal to b squared, so negative 8 squared minus 4a, which is 2, and c, which is 3 minus. And so here we get 64 minus 24 plus 8k is equal to 0. Here we'll combine our like terms. We get 40 plus 8k is equal to 0. We get 8k is equal to negative 40, and therefore k will be equal to negative 5. Okay, this next example, it says a quadratic function is defined by f of x is equal to 3x squared plus 4x minus 2. A linear function is defined by g of x is equal to mx minus 5. What values of the slope of the line would make it a tangent to the parabola? So remember, tangent to the parabola means that it intersects at 1 point of intersection. So that means there is 1 point of intersection. And 1 point of intersection means that the discriminant will be equal to 0. And so here again, we'll make f of x is equal to g of x. So here we can write 3x squared plus 4x minus 2 is equal to mx minus 5. Here we'll move the mx to the other side, so we'll subtract by mx, and then we'll add by 5 to both sides. So here we have 3x squared plus 4x minus mx plus 3 is equal to 0. And here, with the 4x minus mx, we're going to factor out our x value. So here we can rewrite this as 3x squared plus 4 minus mx plus 3 is equal to 0. So here we see that 3 is our a value, 4 minus m is our b value, and 3 is our c value. So here we see that discriminant is equal to b squared minus 4ac. Here our discriminant is equal to 0 because, again, it's tangent to the parabola. So here we get our value. We get b squared. So 4 minus m squared minus 4a, which is 3, c, which is 3, is equal to 0. We'll expand the 4 minus m squared. We get 16 minus 8m plus m squared minus 36 is equal to 0. We'll collect our 16 and negative 36 in terms of like terms. We'll rewrite this as m squared minus 8m minus 20 is equal to 0. Here we'll get our two answers. So if we factor this, we'll get m minus 10, m plus 2 is equal to 0. So two answers here are m is equal to 10 and m is equal to negative 2. So again, both these answers would make the slope of, the slope of the line was m is equal to 10 or m is equal to negative 2, it would make it tangent to the parabola. Okay, so here, let's look at this one last question here in this extension in a quadratic and quadratic systems. So it says determine the possible points of intersection between f of x is equal to negative 2x squared plus 3x minus 5, and g of x is equal to x squared plus 4x plus 1. And so similar to the linear quadratic systems we've done, we're going to equate the two together. So f of x is equal to g of x. So here we have negative 2x squared plus 3x minus 5, and that's equal to x squared plus 4x minus 1. Here we'll move everything to one side. So here we'll add this by 2x squared, add both sides by 2x squared, subtract by 3x to both sides, and we'll add by 5 to both sides. So here we'll get 3x squared plus x plus 4 is equal to 0. So here, if we try to put it into our quadratic equation, so here we have x is equal to negative b. So here we have negative 1 plus or minus square root b squared, 1 squared minus 4, a, which is 3, c, which is 4, over 2 times 3. Here we'll get negative 1 plus or minus square root negative 41 over 6. Now what we notice is that the value under the square root is negative, and therefore there is no point of intersection. Here, really, b squared minus 4ac, or the discriminant, is less than 0.